My hair is starting to get long again. Might have to cut it. But I'm lazy. I don't want to cut it. I don't want to do anything. Just want to sleep. Sleep forever. It'd be nice. I didn't think I was gonna stream today, but I'm bored, so I figured I would stream. And I rearranged the room again, but I think this will be the last time. And I'll tell you why. Because I got everything, almost everything done, like set up in the way that I wanted it. I got, um, I'm not on the Wi-Fi, I'm on like an Ethernet cable. So I wanted that. I wanted a way to prop up my feet underneath the desk, so I got that. Um, and I wanted to be kind of like away from the windows so there wasn't so much of a glare. And I got that. But to get all that done, I had to put the desk like almost in the middle of the room. It looks really goofy, but um, I think it'll work for now. I mean, there's still room for people to sit over here or behind me. Um, but nobody really visits me anyway, so you know. So I didn't do anything today. Um, well, I did do a little bit of stuff, but it's a rainy day today, so nice to stay indoors. And well, it is Sunday too, isn't it? Yeah, I bet a lot of people are just chilling inside. Or have to go back to work tomorrow. Oh. So today, oh yeah, I guess we'll go over that. So last stream we were working on this here. Let's go here. So it's the starting soon screen. You have to give it some text. This is the Mega Man Legends OST. Yeah, this is working. This is hosted online. It's here if you want to mess around with it or use it for anything. I don't know if I'm completely done with it, but this is what we did last stream, and what's cool about it is it tries to mimic, you know, the ps1 graphics, and it does like three main parts of that are the vertex wobbling, the affine texture mapping, and then the limited palette, like 30, or it's like they do like 5 bits per color. So nowadays you have like 8 bits per color, right? And that's 2 to the 8 should be, I think you have to do it like this. You know, yeah, that's normal. So think about CSS, you've got 255 possible colors in each channel. Each channel has its own value. But back in the day with the PS1, they only had 5 bits per channel, so 32 bits. Oops. So they could only do like 32,000 colors. So that's part 3 of this, is reducing that color, like quantizing the color, and then doing the dithering as well. Because when you reduce the color like that, you get noticeable banding, like color bands and stuff. But all of that's in this project here, but I kind of want to split out each of those pieces into its own little like mini demo, because the thing that I want to do is make a little blog post about this. And I don't want to show everything all at once. I just want to show like, here's the pieces that come together, and then we'll have like a big, like a project like this in the end. Like at the end of the article or whatever, that shows them all working together. So that's the goal for today, is make a little demo out of each of those. So one, you've got the vertex wobbling or snapping. Yeah, vertex wobble. Number 2, you got the affine texture mapping. And then number 3, you've got the reduced palette, or what would you call that? Like color, we'll just say color. Color plus dither. And then maybe we'll talk about like lighting or something in the article. I was watching this video. I can see if I can find it. I think the guy's name was Huma ps1. Yeah, this video here. So this goes into a lot of detail about yeah, how PlayStation graphics work. This is was a really good resource that I found in between now and last stream. So I'd recommend people to watch that. Oh, I'm not logged into the Twitch chat. Oh, hold on. Let me sign in. People could be chatting, I don't even know it. Oops. Why can't I paste in these? I hate that. Mobile phone, hold on. It's my phone. My phone. Okay, there we go. That's the video link. And where the lighting comes in is like, you have to kind of like bake in your lights into the texture. The way that you do that is with like Garud shading. So according to this, the ps1 could do these primitives: line sprites, flat shading, which is one color per face, Garud shading, which is each vertice has, or each vertex has like a light value or a color value, I suppose. And then those are interpreted, you know, across the face, or like across the triangle or across the quad. So like here, you know, it's going from red to blue, and it's linearly interpolated along that edge. And then it could do texture polygons. But I don't know if you could do both, because nowadays what you can do, very easy to just take a map, you know, texture, and then sample from that texture in the shader, and then you know, if you want to attach like vertex colors to your vertices, that's super easy to do. And then you just take that vertex color and like multiply it by your map value, like the color that you got out of sampling the texture. Because we can do either one. We can, but it'll be much easier to do like vertex colors plus a texture, rather than having to like bake the colors into the texture. But I don't know. I gotta see if that was like what the ps1 could really do, or if this is true, like you get this or you get this, you don't get them both combined. So yeah, so right now we're working in this, I can't really tell, but this is the graphics glossary website that just kind of like has all the little demos that I make in one location. And it's supposed to be like, oh, what does this mean? Like, I've heard of the cool horror filter, what's that? And you come here and then it loads up, you know, a little demonstration of the cool horror filter. But one of these I want to work on today is ps1 graphics stuff. And what that means in the long run probably is that we might have like shorter articles like this, which is really just one little demo, and we might have like case studies. And I think there's kind of one right here. This was a pretty short one, but if we do this ps1 style stuff and we do little mini demos, it'll be like a longer blog post. And so I might go in here and separate, you know, longer case study stuff, more detailed articles, from just little simple like, here's what it is, here's how to use it, you know, simpler stuff. So more complex stuff, simpler stuff. But that's something that I'll have to do probably off stream. But we will have this little like playground to work in, and there's nothing in the screen yet or on the canvas yet, but that's what we'll work today. And the first little demo that we'll work on is the vertex wobble. So I won't like talk about the details of this, we're just gonna implement it. If you're interested in like where this comes from and how to do it and more explanation, you can watch that YouTube video, or you can check last stream, which might not be on Twitch anymore. It might be on YouTube now, but my YouTube name is the same as my Twitch name, so you can find it pretty easily. And I uploaded all the VODs. There's only one in this like series or whatever, but you can find it from there. And I think it might even be linked on my Twitch now. like on the About Me section. Let me confirm that. Yeah, it is. Sweet. Okay, so this will be pretty simple to do. But I got a little scene set up. I don't have anything in the scene, but what I want to work with first, I think it'll be best to work with a really simple like shape and a really simple texture, and that way we can confirm if things are working properly or not. So the one that I think works really good. Oh, what happened to all this? Oh. Did everything get... Yeah, that's weird. Okay. Yeah, let's make a little shape, or a little mesh with a texture on it. Let's make a plane geometry. You see this website where this music was playing has this problem where it just... Okay, it is still playing. It must be just like a really quiet sound, or a song. Anyway. So we'll need that. We'll need a node material here. So just probably a basic one. Mesh basic node material. And these node materials allow you to use TSL. So they just extend from their like, you know, their normal material counterparts, but they have this node thing right here. And if you go here, it says, you know, it extends from node material, which extends from material, but you know, this is the equivalent of mesh basic material. So we're working in the vertex wobble, so we know that we're gonna have to do stuff with the vertex node. But before we do that, let's at least like see something on the screen. So we'll make a map. And this we'll get from an off-screen canvas texture. Let's make that real quick. We'll make a size. Size. We'll get the context. So I'm just gonna make a checker pattern on here. Exactly what we did last stream. So if this context is null, which could happen, but not in our case, we'll just, you know, we'll just return out of here. Yeah, we should be able to do that. Are we in a function? I guess we might be in a function. Yeah. Let's remember to add this to scene.add mesh. This needs to be t.mesh. And let's make a texture out of this canvas. So that's we'll call this. No, I guess it's not dot texture. Oh, well, we can just call this map then. Let me get rid of this. Right. So let's draw to it. So we'll take where or this will be j less than size. And then same with the Y. And if I plus J is even, then we'll fill, we'll take the context and we'll fill a rectangle right there. This will be at J, or at IJ, and it'll be 1, 1. Okay. There we go. Oh, we need to set the fill style of the canvas, or the context. Is it black? Is it white? I don't remember. Oh, we need to move the camera back. Yeah. So let's take the camera and we'll translate backwards 5 units. There it is, but it's blurry. And the reason why is that the texture does map and filtering. It does like min-mag filtering on it, so let's disable that. That's an important thing to do if you're trying to emulate ps1 graphics, because they did not do this. So we can't do it either. So where we create the texture here, we'll just take the map. And we'll set it to nearest filter, and then we won't do mid mapping. Yeah, let's bump up the amount of squares. And then I want to center the camera on this thing, so I have a little helper function to do that. It's called fit camera to object. We give it the camera and we'll pass it in the mesh. And it will fit it like 100% in this case, you know, where it's against the top here. If you want to offset it a little bit, give a little bit of a buffer or like padding, you can do, you can give a little bit like this. Yeah, there we go. I guess I should have explained that we're displaying at the normal like resolution, like the viewport size here is 320 by 240, which is native to the PS1. And then we're setting the canvas to be that size as well. The camera needs to be updated. Oh no, we are doing that. So the aspect ratio when the camera's created is, you know, 4:3. So that's good. We are displaying the canvas at a larger size, but we need to turn off the, it will do, what do you call that? Anytime you have to like scale up or down a canvas or an image, it's got to do some kind of algorithm to know like what am I going to put. You know, if I'm scaling up, now I have more pixels than I normally would. What am I going to fill those pixels with? And to do like the same thing where we don't do any filtering here, or we do nearest filtering, the equivalent of that in CSS is this property called image rendering, and you set that to nearest, or what is it? Pixelated, that's what it is. So a different name, but the same thing. And now, you can tell, I guess, that it's much more pixelated. Maybe, I don't know. So now we can turn on the vertex wobbling. This will be super easy. You can set the vertex node here. And this is explained, you know, all over the internet. I can know that because I've done a lot of research on this. So I'm not going to go into too much of the details. I'll just mention that this is done per vertex, like in the vertex shader, which is a good thing. Because it means that you're not doing it per fragment, and the ps1 could only do integer like vertices, so what we're going to do is make it so that these vertices are floored to the nearest like integer, and then we're going to pass that along, you know, to the rasterizer and stuff. That part where it like the rasterization part, we don't have to touch it or have control over it or anything. That's just something that is kind of like a black box. Like we send these vertex information to the rasterizer, and it will figure out how to fill the pixels to make the triangles and stuff like that. So it can do what do you call that? Like sub pixels. You know, if you draw a line, I don't want to explain this too much, but if you had some pixels here, and this is like super zoomed in, here's your pixels. You know, it would say, okay, well this line touches this, it touches this. I'm going to fill in all these pixels that this line touches. You know, something like that would be your line. And this is like super zoomed in. But if I'm not mistaken, the PS1 couldn't do this. It only knows the pixels where it only knows these pixels here. And we'll see that too. I'll put in a little like uniform here where we can turn off and turn on the vertex wobble, and you'll see like there won't be as many pixels that get shaded because, you know, it doesn't know that it can fill in these to make a more like smooth kind of line. But to do this, you need to get the clip space, or yeah, like the clip space coordinates. So you take your camera projection matrix, and you multiply that with your position in view space, and this will give you the clip space. So let's save that somewhere, that'll be helpful. And you need to import this. So these TSL imports, do I have any? Yeah, right here. They're living under TSL, so it doesn't know, like this is namespaced under T. So like I can't do just T dot position view because they're not in that library. But if you just do clip right here, you'll see that there's no difference in the output. And this is what's normally happening in your vertex shader. But we need to take the clip, and we need to take its XY, and we need to divide by clip.w. and then multiply it by the viewport size. This will also import if it lets us. And then we do the flooring. So what we did here was we went from the -1 to 1 range, which is this. Divided out by the W, multiplied by... These might be backwards. Let me check. I can't remember if you multiply clip W or if you divide clip W. Okay, you divide. So this will go... Oh yeah. So this goes from -1 to 1. This will go from -1 over W to +1 over W. And you multiply that up, you'll scale it up, you'll floor it to get rid of the decimals, and then after you floor it, you need to go back to -1 to +1. So you just undo what you did in the like before the flooring. So we'll multiply by clip.w and then divide viewport size. Oh, and then this will return a vec2. We need to like this vertex node expects a vec4. So we can just put that into vec4. And then its Z coordinate, or like its Z component stays the same, and then its clip, or its like W component stays the same too. And then it looks like I need to put these here. Or let's see, what am I missing? Clip.z. Oh, dang it, what? Okay, yeah, there it goes. So this now has the vertex wobble, but you can't really tell. It's kind of hard to tell that it's wobbling. So let's put in a uniform where we can control whether that's enabled or not. To do that, come up here and we'll make a wobble uniform. We'll set this to false. And then here, this can actually live. Well, let's see. We don't want to do this if wobble is enabled. So maybe what we'll do is we'll select. The select takes a boolean, you know, this is kind of like the equivalent of a ternary in TSL. We'll select wobble if it's enabled. We'll take the first argument. And if not, we'll just take the clip. But now we need some way to control that, so let's add our little pane component. We'll make this relative, and then we'll put a pane container in here. And put it at the top right. Oh, we have to import it, looks like. Where is it? Where's our pane container? Maybe we need to import the pane. So we'll attach pane here. Let's see. I don't remember how to do this. Attach pane. Yeah, and then this argument here is the configuration. And I might want to change this. I kind of want the config to happen last. Like either of these, I don't know, you should be able to make a pane either way. Whether you pass in a config or you do something with it, it should create something. But let's leave these off. Yeah, you can kind of see this little bar up here. This is the pane, but there's nothing in the pane. So if we give it a title, uniforms, and then the second parameter here is what do you want to do with the pane when it's created. So we'll just add a binding to that wobble, and it has a value property which we're going to update. And we'll give this a label of wobble. So this is with wobble. Let's see, wobble is, let's turn it on by default. You can kind of tell when it's on and off. You do get a little bit of a different image. You can tell when it's on. It's like hard to tell, and I don't know. Maybe if we turn down the resolution. So it is working, I suppose, but it's just hard to tell, like, is that what it should be doing? And I guess you can kind of tell the wobble here. Or I guess at the vertices. It's not supposed to happen on the mesh, or like in the texture. So we need something with a little bit more vertices, I think. Let's make a box geometry. Or maybe even like a sphere geometry. So this is without wobble. Oh, let's bring up the resolution again. And maybe if we do wireframe, where we can actually see the vertices a little bit more clearly. Oh. Like, I mean, it's hard to tell because that map is coming through. Oh, and then we need a color on it. So let's do this. Let's make the color here. We'll say if it's even, we'll set the color to, I don't know. What's a good color? Orange. Else, we'll set the color to maybe blue or something. Purple. We don't need to do that. And then let's make it, I think if we do an icosahedron geometry and we set its like detail really low. Okay, this is with wobble, without wobble. Yeah, I'm looking at this thing here, and then just going like from left to right, like right there, you can kind of see it like dips down. Hard to do like perfect, left right on the mouse. But maybe if we rotate this thing, so let's take the mesh down here. And we'll rotate around the Y. We'll do like 0.01, maybe even less than that. Okay, it's not rotating. What's the deal? Oh, this is in the wrong spot. So that's with wobble, and then without the wobble. And it's a little too slow, I would say. Maybe I should add back in that map. Or we do have it. Let's turn this off. So that's with the wobble. So it should be smoother without the wobble. Let me pause it. And you can tell that the vertices are different. Is this how it mapped a sphere as well? Kinda. We go like very low poly. Okay, let's do like 8. What is this called? Box geometry. Need to zoom out. Yeah, where are we fitting it? Right here. If we do like something very small, I wonder what that looks like. Well, you can definitely tell there, like, these all get cut off during wobble. Well, I believe it's working. I mean, it's still not to my liking, but I'm just going to say that it's working. Yeah, so this is pretty much demo number 1. Um, Let's make this plane geometry. And we don't have to display the scene, we can just display the mesh right here. If we want the white background, we do have to put it in a scene. But what I want to do here is rotate it around the z-axis. And they say, like, you can definitely tell the wobble if you're rotating, like, very slowly. Like, even this is hard to tell. I don't know. I just like the really low one, low poly one. I like low resolutions. Let's just give it like a random rotation. Not random, but where we make the mesh. Maybe like rotate it like that. Maybe a little bit less. Yeah. It's like hard to dial in, like what is the sweet spot for all these demos. We get really close. Let's see. Now, like where you can get really close to these pixels. Ooh, so close. Yeah, look. Oh. I think you can kind of see it's more jagged here. With, well, I don't know, with the wobble on? Is this going nowhere? Probably. That looks pretty good, right? Yeah, I think 4 is good. Oh, I have this in the wrong spot. Look at that. Did I change anything? No. Okay. Curious what we do. What happens if we bump this like way up? Oh, that looks like Z fighting, but we turn on the mip maps. I think that might go away. Yeah, that's a good mip map demo. Oh, we need. Oh, look at this. Look how weird that looks. Sometimes you get these spiral patterns. Oh, and there's another pattern. Like this is kind of like moray patterns or whatever they're called. Oh, look at that one. Yeah, this is pretty interesting. Wonder if anybody's ever explored that. There's another interesting one. I lost it. Alright. Okay. I'm going to move on to the next thing. So let's copy all this, because I don't need a GLTF loader for this. I must have been from copying and pasting elsewhere. Oops. Okay, so the other part is the affine texture, or let's just call it affine mapping. And then we'll steal all this. Right here. Yeah, this is the right one. And then what do we call it? Affine mapping. Okay, so it's the same, but now we're loading that component instead. So to do the affine texture mapping, and this is only supposed to show off that part of it. So the vertex wobble, well, I don't know. Maybe we should work up to this. So, do we leave it in, or do we just demonstrate it in only that part of it? I don't know. Let's just do that, only this part of it for now. So this happens on the color node, and make a function out of it. So what we need to do is undo the like perspective correction. And for that, you get the normal UV, which I'm going to do in the vertex stage because we multiply it by W, and then now we're outside of the vertex stage. So whatever we do here will happen per fragment, and then we yeah, we do that. So the affine texture mapping, now we're talking about colors. So we don't need this map anymore. Instead, we'll get our color in the node material here. We'll take the texture. This comes from TSL. And we pass it in a texture, which is the map. And then it takes this UV parameter here. That's what we want to return. So this is our UV. This has to be here. Okay, let's import the things that we're missing. Yeah, there's the whoa, look how it looks almost like a like a paper airplane or something. So again, like I won't talk about how this works. I'll just say like it's online all over the place, especially on YouTube, and refer to the like previous stream if you're curious about why this works. So that's the affine texture mapping. That one's done. Maybe we don't rotate this one. Oh yeah, we gotta rotate. You can't tell that it's working. We can't tell it's working there either. Kinda have to tilt the camera to see it. So maybe what we should do, we can either move the camera or we can move the mesh. Those cameras, you know, hooked up to orbit controls. So it might be easier to like wiggle the mesh about or whatever. So we'll take the time here, and then we'll take the mesh and we'll rotate. We're gonna rotate along the y-axis. So this is the amount that we rotate, and we need to take so this will go, yeah, crazy. That's what I thought. Let's turn it down by a lot. Yeah, even more than that, I guess. I guess this is adding on to it. But we want to rotate by a specific amount every time. And then if we go like, you know how sine goes up from -1 to 1. An easier way to do this is just to set the rotation. Maybe pass time in here. It's not the X. Yeah. And then we'll turn it down. And there you go. Now it's like you can definitely see the affine texture mapping in that. That's pretty slow. Let's go like 1/2000. What is that? Maybe we don't go by as much and go like by half. Oh, but that's a lot slower. So it kind of looks like it's like moving. But that's only just rotating. Let's turn off the yeah, let's like enable and disable the affine. Okay, so here we'll do the same trick. If the affine is on, well, we can do this. Select affine. If that's true, we'll take that. Otherwise, we'll just take the UV. There we go. Whee! You know, if you ever build a website, you should definitely test like this. Like, you know, you put some controls on there, or a checkbox or something, and you have a listener on the checkbox. You should test it like this. Because this is what a user will do, you know? So if you have to do something like asynchronous, or maybe even like a network request for some reason, let's just say like something crazy on this input event, you know, you make sure that you're not sending off like multiple requests when you do this. You know, you should abort the like in-flight request and stuff like that. But you know, that's a different topic. But it's always fun to go and like try to break websites, like, you know, try to push them to their limits. And you could tell a website is well coded if, you know, it can handle crazy user interaction. Maybe not well coded, maybe like, you know, they've got defense mechanisms or something for these kinds of things. Not that it's like a malicious activity or anything, but you know, the website's not going to break if I'm doing this. I mean, we're just working with graphics, so of course it won't break, and it's just a boolean. Um, but if something was like more complex, tied up in this input or something, or you know, if you had like a form controls or form input or something like that, or if you're making like a user interface and stuff, like over here, imagine if you know, selecting these like this or whatever crashed the app. We don't need this. We don't need this. We don't need this. We do need that. Okie dokie, so I kind of want to, now that I think about it, go here. And I want to consolidate a little bit of this. So this can just be a ternary. Let's say orange. Let's copy that too, because that is the same over here. And then the other thing is these, like this doesn't have an FN, which is nice. So I didn't have to like make a function out of anything, you could just inline it all. And I wonder if we can do that here anywhere. Like here we can put this here. Get rid of that. And then we don't have this anymore. Is that it? No, what am I missing? Okay, there. And then we don't have to do this. You can just return this directly. Yeah. So this kind of reads to me like, you know, we're taking a texture and we're sampling from this map, and these are our UVs. And in the UV, we're like switching on affine, and it would be nice if this was something like this, but the formatter won't let you do this. So let's pull it back maybe just a little bit more. You can tell like where the line is at for the triangle. Like it's not here, it's doing this line here. And you know, just to confirm all that, you can actually set the wire, well, I don't know, can you? Yeah, you should be able to. So it like skews it along that, yeah, along that like triangle, the hypotenuse. Well, actually, I mean, it like skews the whole thing, but it's easy to find where the triangles meet. I don't know why you would ever need that, but maybe there's some workflow out there or some visual effect or something that, you know, knowing where the triangles meet up, knowing that fact would help you. Okay, so that's demo number 2. Demo number 3 was the... Oh, I don't... Yeah, I can do this. I haven't prepared it for today, but we can do this for sure. So let's make a third one here. We'll call this colors. Now, it should... We should make a texture. So to show this off pretty easily, we'll make a texture, a canvas texture that has a radial gradient. You know, I might refer to some of the Throat code to do that, because I know in Throat there's a radial gradient component. And the reason why I want to use a radial gradient is because once we reduce the colors, we'll see the color banding very well. So let's go to the source code of this. Which I think this is broken, yeah. Okay, so I just need to remember how to do a radial gradient. Okay, that's pretty easy. Oh yeah, and then I made, yeah, okay. Oh, we have this twice. I don't want this twice. See, this is where, you know, component, or like, moving these things into functions would help. But that's kind of like a boring stream topic, I think. I don't know, some people like watching people refactor. Okay, and then we probably should use the colors app. So here, rather than make the checkerboard, we don't even need this either. Look at all this stuff I forgot to clean up. Yeah, so rather than make the checkerboard, we'll do a radial gradient. So we'll do context, create radial gradient. So this guy here will be size over 2, size over 2. And then the inner radius will be math.hypot of size over 2, size over 2. And then or what's the inner radius here? Oh, 0. Okay. So this is 0. Then we have outer, okay, we have half and half again. We probably should move size over 2 into a variable, so call that half size. Okay. So that should create our gradient. What does that return? Canvas gradient. Wow. Now this add stops, what is that? Let's go there. Where does that come from? Common. Why didn't it filter over here? I don't know. Okay, we'll grab this. So what that does is for every color and offset of stops, we add a color stop to the gradient. So I guess this defines its size, but there's no colors inside of it. And then this adds the colors to the gradient. Okay. So we just want 2 colors in our case. So what does this add stop take? It takes a number and a color. It's probably at 0 we want orange. And then at 1 we want purple. Oh, and then we can just take this and put it down here. And then how do you apply that? Or how do you draw that? Oh, you said it has a fill style. Okay. So grade, let's see. OSS, no, context dot fill style equals the gradient. and then you fill the whole context, or you fill the whole canvas. So context.fill rect 0, 0, and then it's size and size. Did it work? Yeah. Still, you know, if we like upped the resolution here. Oh, it's the size, that's the problem. Yeah, so we need to up this maybe to like 128. So there's our gradient. Let's turn off the rotation. And you always gotta wonder if this looks better when it's reversed. Nah, it's like the same. What is this? Hmm. I'm still doing the affine texture mapping. We don't want to do that. It's not the map. So we might need that. I'm going to keep it for now. Let's set this as well. We'll say enabled. We might change that later. This is right, this is right, yeah. Okay, so to do the color banding, or to do like, you know, from all the colors that we have to work with today, to quantize that down to like what the ps1 had, you take the color node, and you are going to sample from your map texture, your normal UVs. You need the RGB of that. So let's take this and inside of a function, and we're going to return some vec4. Say 1. Okay, so this color now, when you sample from a texture like that, you know, colors in GLSL and so on, they go from 0 to 1 each channel. This is just the RGB component of the color. And we know it goes from 0 to 1, so if we scale it up to 255, you know, because every channel now has 2 to the 8 bits to work with, so we can multiply by 255, and then we need to scale it down, so that's like scale it all the way up, and then if we scale it down by 2 to the amount of bits that we have, I think. Or no, it's like this. Let's see. I'm just gonna pull this from the current project, or the Text 3D project, so that's here. And it's these values. Oh yeah, but this needs to be post-processing effect. So let's do it here, and then we'll move it into post-processing. So this is the quantized color. We're just gonna steal all this. Yeah. Is that really all of it? That's a lot. Don't have the dither yet. This is called map. Okay, so that should work on the mesh. And there's the color banding that you see. So that looks correct. Well, we want this to be applied, to the entire scene. Right now it's only applied to this mesh. So we need to grab a hold of like the scene as a texture. Let me switch the audio. Yeah, so if you wanted like even more banding, you want to reduce the colors even more, you would change this bits. So if you're simulating a system or something that had only like 3 bits per channel, as this goes down, the number of colors goes down. That's 2 bits. So that's like extreme color banding. But this can't go more than 8. Because here you would be... Well, let's see what happens. Okay, yeah, so if it's more than 8 or whatever, it's just going to be like clamped to 8. But let's move this to... We can even steal the code from here. Oh, not this one. Steal it from here. So we need all this. Copy that. This render pipeline, it is an add-on, I think. Oh no, it's right here. Pass it in the renderer. And let's take that and we'll dispose of it down here. I haven't really been disposing of other things, but this one's easy to dispose of. And again, we don't have the dither. This is called map, or yeah, this will be called text. Because the text will take from up here. Or no, it's right here. So that's an import. We get the text, that's good. And now we need to render a scene. Do I still have scene around? Yeah, where's this guy? Oh, he's right here. So that means over here they also still probably have scene. Yeah, right here. And this one too. Okie dokie, so rather than rendering, oh yeah, we're not using the time, rather than rendering with the renderer, we need to render with the render pipeline. Okay, let me double check now that this is right. I guess we can go over here and make sure. Oh yeah, we need to make a scene and add it. We need to add the mesh to the scene. So we'll come down here, move this over here. Alright, that's nice. So now if we add more than one object in the scene, everybody's getting this color reduction done to them, because now it's a post-processing thing. That looks pretty nice. It looks like a sun or something. Even though it's supposed to be orange, like it's not very orange. So, like, what does yellow look like if that looks so yellow? Okay, it's kind of like whiter, I guess. How's this if it's pink? Yeah. Well, purple is pink. And this is a tone mapping thing, I think. But I think it looks pretty good. We could also change the... We could either like set this to be an enabled thingy, or, you know, you can have this be a uniform as well. But you would have to calculate all this on the GPU, which isn't that bad. But I think I'll just keep it under a keep it tied to a boolean. So right here where we've got the color, and then we quantize the color, what we can do instead, and this is interesting because if the uniform is true, you know, we can just return immediately like that color. And you can either do an if or you can do the select. So let's do return select, and that was under enabled, right? And then we'll do vec. Oh, let's do it like this. We'll do vec4 that one. Here we need the color. I know if it's enabled, it'll be quantized color. If it's not, it'll just be the color. So this will take here. We have this already being returned. So it should now not calculate this, I would assume, because this is like short circuit, or it's kind of like if this was some expensive calculation, it knows that if this is false, it doesn't need to perform that because we're not returning that. But I don't know if it's like that smart or not. I'd have to look at the generated GLSL to be able to tell. But let's see that this works. It doesn't work. Oh, wait. Is there a way to do this? Hold on. Let's go here. Nice. Okay, well, why isn't this working? I guess it's because... What's... It looks like it's... Something's happening, but it's, moving the bands or something. Shouldn't be doing that. Hmm. I'm thinking that I want to turn this into a quantization app, and then the dithering we'll do separately. So we'll name this the quantization, or color quantization. And then in the app here, let's make this a uniform. We'll set it to 5. Let's say the max. Well, we'll call this bits. That'll be 8. And then let's say you can go down to like 1, I guess. Call this min bits. Alright, so this needs to be 255. Oh, we don't need to clamp it anymore because we're not doing dithering. When you add in the dither, like the actual dithering that the ps1 would do, that number could go out of bounds. So you'd have to clamp it to the maximum. And, you know, it could go out of bounds on either side, the minimum or the maximum. But here we don't have to worry about that because we're not doing the dithering in this app. So that's a uniform. Let's say that the down is now oh, let's do it like this. We'll do it one at a time. So bits, we'll do float to how bits, and then we'll do what's up? That's 255. So let's put that in a variable, or let's put that in a node as well. And then we can do up.div that, but now we can actually, well, what's the opposite of taking a power, or raising something to a power? It's doing like the root or whatever or something, right? Well, that's in the square case. If it's like, you know, something to the third, then you have to take the cube root, and you have to take the fourth root and all this stuff. Yeah, so we'll just do that, and then we'll seal it. And that will be our down. Okay, then we do this, and then we divide, we do up.div down. So now we're not selecting between these two, we're always doing that. Which means this can go here. You can tell, like, with this TSL stuff, there's a lot of chaining going on. So let's just return this directly. So we should still see something, but we're not. Okay, let me make sure this is correct. So that's going to be, let's go here. Okay, first thing we do with the colors, and multiply by up. That's 255. That's correct. Then we div by down. Well, we don't have to do this clamp, we just div by down. That's correct. We floor it, that's correct. And we divide by up over div dot down. Or up over div. Up. Yeah, up over div down. Okay. It's just calculated correctly. So we take up dot divide, float to the power of bits. And we seal that. So that's right too, right? Oh, what's this? Yeah, we'll do bits, and then we'll do, yeah, label. Here we'll do min of min bits, max bits. And then a step here is just 1, because you can't have like half of a bit. Oh, sweet, it's back. Okay, so we're at 5. If I, yeah, there we go. But that's not right. That's not right there. I think it might be because of the floor. So this floor, yeah, this floor is messing things up. But no, this is kind of like, you know, if your color, when you scaled it up and down and all this, it's just flooring the color, kind of. If you take something in between this range of 0 to 1, you map it up to, you know, if down is equal to 8 here, this would be up divided by 2d8, which is 1. We seal that, which is 1. So this goes away, this goes away. You're kind of just scaling up to 255 and then truncating it, or like, you know, flooring that. You'd have to take like bits, and you'd have to, you know, take like 255 or something here. That would be some, yeah, 2 to the power of 255 is probably too much to calculate. This is 5. So yeah, this is different than just turning it on and off. If it's enabled, it's gonna do this flooring thing. I don't know if I want that to be... I kind of like this. I mean, you could definitely tell what's happening like in the lower numbers. At higher numbers, the banding is just like, I don't know. If you allow this to go up to like 15, you still get banding, but if the result is like, you know, you can't really tell the difference between this and this at the higher range, at the higher numbers. I gotta think if I want to make this. Oh, I should, right? I should make this, you know, something that you flip on or off. But I'm gonna leave it like this. I won't do that on stream. You know, whether we're gonna reduce to 32,000 colors or not. Because this is all about reproducing the ps1 graphics. It's not about showing how to floor your colors and get color banding. So I'll leave it like that, but off stream I'll make that change. Let's see if we got a little bit of time. Maybe we can do the dithering. I'll just call this dither. And we'll steal this. Oh, let's see. What do I need? We'll need that. Dither, we'll put that. Okay, so let's make sure that we're loading that app now. There we go. So over here in Dither, we have the same thing happening. Pretty much the same, but now what we need to do is add the dithering in here. And I think, you know, we can also put this behind a flag, or behind a boolean that says whether the dithering is on or off. So this might, yeah, I'm thinking like these two should probably be combined. And this will be the case where we're not just showing off one thing, we're going to show off everything about coloring. The quantization and the dithering. So yeah, let's get rid of this. We'll call this color again. Oops. Oh no. Don't do that. Okay, hold on. Go here, let's go to components, examples. ps1. Oops, this will be app.svelte. Okay, in the playground, we need to load colors. Nice. And then over here, let's go back to colors. So, over here, we're already doing the clamping, that's cool. We'll do add some dither amount. And let's do select, or it's like, what are we gonna add to this? We don't even need to do the clamping either if we're not adding, but I'll figure that one out later. We'll do dither enabled, dither, or let's see. Yeah, these are just values, so we can just do 0. I mean, they're just numbers. Now we need a boolean for that, or we need a boolean. We need a uniform for that. Dither enabled. Oh, enabled. Oh, I had something in the buffer or whatever. Let's see. Okay, that's nice. So we need to calculate the dither. And that again we can pull from here. Where is it? Dither. Right here. Let's do the same thing. We'll put it in the module tag. We got our dither, so we need to call it right here. And then let's link up the so this is dither enabled value label Can you see that? Let's see. Let me turn the dither on by default. Ah. Where's my error? Oh. I need to get those values again. They are down here, they're down here, right? Right here. So, is this still a function? No. Let's put these here, I guess. Oh, and this is on the... Oh, crap. This is on the... We lost our, Yeah, look at that. This color node thing needs to go away. It's this texture of the map. Right. And down here, yeah, we don't need this. Don't need this, don't need this. And if that's the case, we can just call this map. This doesn't need to be a node material anymore. We lost the color banding. No, we didn't. I'm just, yeah, look at that. Look how good the dithering is. It's hard to, like, when you're so far away from it, it doesn't even look like it's banded anymore. That's pretty cool. Why is this in this soundtrack? Okay, so what I want to do now is make a boolean that can control whether the banding is even happening. But you can imagine how that would go. Be the kind of the same idea here. You'd select on something, Num, num, num. So, yeah, I think that's, that's kind of the end. All these things will come together in that. So imagine that this is now a web, or it's one of the, maybe this, I don't know, I gotta think about it. Either this will be a blog post or it'll be its own little page on this website. And those are two different sites. Um, but yeah, if you can imagine now that, we'd have Colors app, and this is Vertex Wobble app. What was the other one? Affine mapping. And here we have all three of these. And it'll probably go in this order, so we'll do Wobble first, then Affine. Oh, I got these backwards. Yeah, so in between each of these little demos, it's going to be, text about this, text about this, and then text about this. And then in the end, we'll make a scene or something that brings all of these things together, all these ideas, all these shader stuff. We'll bring it all together, and we'll make a little like demo ps1 scene. And I have a GLTF already picked out for that. But that GLTF, when you load it, it comes with the materials, so you have to traverse your scene, your GLTF scene, and you have to modify materials on the mesh and stuff. And that's not necessarily about PS1, but it is a good thing to show off is how do I modify materials and geometries of like external assets and stuff like that. So that's what we're gonna do. And then like actually putting text in there and doing almost like the docs of it, because it's pretty dry stuff. Maybe I'll stream that, maybe not. um, that's where you have to be very careful about like what you say. You don't want to get things incorrect. You don't want to be wrong on the internet. There's no way to. Well, I guess people can make a PR to the project and tell me I'm wrong about the wording of something or the terminology or stuff like that. Um, so next stream maybe will be Thursday. Gotta work tomorrow, but I think Thursday will. In between now and Thursday, I'll think about how we can do the Garud shading. Like make a demo for that. If I do stream on Thursday, what we'll do is we'll make that final like whole enchilada demo where you get all the PS1 stuff in one scene. We'll definitely do that, and then we'll definitely do like modifying the GLTF materials. So we'll do that at least. I think that, and if we have the time, You know, it's either gonna be we do just that or we actually throw in another demo or whatever in there for the Garud shading. So, yeah. I don't know if it'll be an evening stream like it was today. And it will probably be sometime around 12 o'clock on Thursday. So be aware of that. I'm going to sign off. Thanks for watching if you're here. And I'll see you guys on Thursday. Later.